Welcome to True Projects. In this video, we are going to explain about the project that is Automated Network Intrusion Detection System for Internet of Things Security Enhancements. Before getting into the execution, first let us understand what is the project about. As we all know, the internet has become an integral part of our lives. And with that, the amount of sensitive information being exchanged has increased significantly. This is where cybersecurity becomes a major concern. Hackers and attackers are constantly they're finding ways to exploit weakness in systems to access your private data, which is why ensuring confidentiality, integrity, and availability of the data is so important. To protect against these threats, we do have network intrusion detection systems used. Think of them like a security system that monitors network traffic, looking for unusual or suspicious activities that could indicate a cyber attack. They can help in identifying when something is wrong, so the issue can be addressed before it becomes a major problem. However, with the rise in the Internet of Things, devices like smartphones, appliances, wearables, and connected cars has made this even more complicated. These devices communicate with each other and transmit a lot of data across various network layers, making them vulnerable to range of attacks like denial of service, middleman, man in the middle, and Sybil. So these attacks can threaten not just privacy but also verify very functionality of the devices and services we rely on every day. To detect these, we do have some traditional methods that are signature based methods and anomaly based methods. Let's talk about signature based methods. These methods they can only recognize known threats so they can't detect new ones. While anomaly based methods they can spot unusual behavior but often they trigger false alarms. That means they can misguide it. They may be misguided that positive ones may be the attack. So the challenge becomes even bigger with the IoTs that are Internet of Networks, Internet of Things, which are complex and have vulnerabilities across multiple devices. Additionally, the data sets that we are using for training, they are of imbalance. That means we do have normal data more than the attack data. That means we have legitimate transactions than the attack transactions. So we need to address this issue. To solve this, we do have some machine learning techniques. So here where machine learning comes into the picture, it can help by improving detection accuracy and reducing false alarms. These methods adapt better to evolving threats, ensuring more robust security for IoT networks. So, to overcome all these problems, the proposed system aims to improve network security in IoT environments using by implementing automated network intrusion detection system using machine learning techniques. So in this project, we incorporate UNSW NP15 and by using this dataset, we will be training all the algorithms so that they will be able to detect the attacks. And from this data set, we will be cleaning the redundant data. We will be encoding categorical variables to numerical variables. And we normalize numerical values for better model performance. To address the class imbalance in this project, we are incorporating synthetic minority oversampling technique. That is nothing but SMORE to generate synthetic samples for minority class, ensuring a more balanced data set. Here, minority class is nothing but the attacks class. For selecting the best features in this project, we are incorporating Pearson's correlation coefficient to remove the redundant features, enhancing efficiency and reducing computational cost. The core of the system, to classify the attacks, we are incorporating random forest algorithm. This is chosen for its ability to handle large data sets to tolerate outliers and classify network traffic accurately. It categorizes traffic into normal and attack types, including generic, exploits, fuzzers, DOS, and reconnaissance. The system's performance is evaluated using accuracy, precision, recall, and FN score, demonstrating its effectiveness. These metrics provide a clear picture of the system's ability to detect both normal and malicious network traffic. The use of machine learning techniques allows the system to handle evolving threats and adapt to the dynamic nature of IoT environments, ensuring robust and scalable intrusion detection. To make the system more powerful, as an extension, in this project, we are incorporating voting classifier, which is an ensemble model. This method combines the predictions from multiple models to create a stronger, more accurate overall prediction. Think of it just like asking a group of experts for their opinions instead of relying on just one. So, by combining the strengths of several models, the system can detect a broader range of network intrusions, which improves its overall accuracy. Along with that, we have developed front end using the Flask framework to make the system more accessible for user testing. This frontend acts a user-friendly interface where users they can interact with the system, input data, and see results. To ensure security, we included user authentication mechanism. To secure the user details, we have incorporated user authentication, meaning that only authorized users can access the system. This ensures that testing is done in a controlled environment and provides a more secure experience for anyone using the system. Coming to the implementation of the project, first, what did we do is we have imported the necessary Python libraries such as pandas, numpy, scikit-learn, and others to facilitate data processing. The next step we do is we load and inspect the UNSW NB15 dataset. This contains network traffic data to understand its structure and the types of information it includes. The next step we do is data processing, where we identify and remove duplicate records from the dataset to ensure accuracy of the analysis. Then we remove irrelevant or redundant columns to simplify the data and focus on the useful features. Then we scale the numerical values to a standard range, helping to improve model performance and convergence, that is we call as normalizing. And we use graphs and plots to visualize and analyze the patterns, distributions, and relationships between different features in the dataset. Then we convert categorical labels into numerical values so the machine learning models can process them. This is called label encoding. Then the next step is the feature selection. So next we select the features by using different methods. We do select features using filter method. This is a statistical method to filter out irrelevant features before model building. Coming to wrapper method. This evaluates feature subsets using a predictive model to select the most relevant features. The next one is embedded of filter and wrapper, where lasso random forest with RFE has been used. Here we combine lasso regression and random forest with recursive feature elimination to select the optimal features. Then this is the proposed feature selection technique, that is the PCC. Here we apply Pearson correlation coefficient to identify and eliminate redundant features. The next step we have is oversampling the data. So here we use SMOT technique, SMOT, that is a synthetic minority oversampling technique to create synthetic samples of minority class that are attacks, balancing the data set. Then the next step is splitting the data set. So here we split the data into training and validation sets to train the model and evaluate the performance on unseen data. Coming to the next step, that is building the model, here we choose an appropriate machine learning algorithm and we build to the model. Coming to next step, training the model. So here the train model is used for training the data. So on the training data, we will be implementing the model to learn patterns and make predictions. And we evaluate them using accuracy, precision, recall, and FN score, and we compare them using the graphs. Coming to the front end part, here we have developed front end. We have developed a web interface using Flash to allow users to interact with the system with a login and registration system backed by SQLite database. And users in the front end, they will be able to provide the network traffic features into the system through the front end, and that will be pre-processed at the back end, including normalization and transformation to make them suitable for model prediction. And that for that data set, we will be feeding the trained model for giving the prediction. So finally, prediction will be given in the front end, whether attack is detected or not. If the attack is detected, it will detect which type of attack it is. Coming to the algorithms used, these are the algorithms used in the project. So we have random forest, decision tree, ADA boost, Bernoulli naive Bayes, KNN, that is K nearest neighbor, and logistic regression. And this is the voting classifier, that is the extension model. We have used it for increasing the performance. To implement this project, we need some requirements that are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. This is the overview of the project. Now let's execute the project. To execute, open the code folder of the project. So these are the source code files. Now let's understand each of them, how will they be used in the project. The first folder is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model files which contain the algorithm information, and this will be loaded into the project code during runtime of the project. And this is the UNSWNB dataset that will be used in the project to train the models so that they will be able to detect the attacks. And here we have notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. And this is the sample file in which we have test cases. So these are the test cases that we will be using in the front end to detect the attacks. Now copy the path of the code folder from the address bar of the file explorer to execute. I'm copying the path. Now open the Anaconda prompt. So it has been opened. Now give the command cd followed by the space, paste the copied path. Now click on enter. Give the command python space app.py to compile the app.py file. So here when you gave the command cd, current directory has been changed to the code folders path. Now we are compiling app.py file by giving the command python space app.py. So now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host, that is 127.0.01 and 5000 port, unless configured differently. So now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. Open any web browser and paste the link there. I prefer Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project which is displayed in the browser, and this is developed using Flask framework. We need to sign up first. So click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see various parameters, right? We need to enter all of these to predict the attack. Let us understand each of them. How will they be impacting the attack? So coming to rate, this refers to the rate at which data is being transmitted across network. This is often measured in packets per second or bits per second. It helps to determine the network traffic volume. Coming to STTL, that is time to live. This field represents the time duration or hop limit a packet can exist in the network before being discarded. It helps to prevent data packets from circulating endlessly in case of routing errors. Coming to deload, it is download speed. This indicates the speed at which data is downloaded from the server, typically measured in bytes per second or kilobytes per second. It indicates the indicator of network performance. Coming to ACKDAT, that is acknowledgement data, it refers to the acknowledgement of data packets received by the receiver in a communication. It helps to ensure that data is received successfully and can also be useful for flow control. Dmean, that is mean download speed. This is the average download speed over a specific period. It provides insights into the overall network performance during time. Coming to CTSRV SRC, this is the source IP address of the server. This is the IP address from which a server sends the data. It helps to identify the source server in communication with the clients. Coming to CTDST Sports LTM, that is the destination port source lifetime. This represents the duration of which the source port is communication remains active in relation to a destination, indicating session persistence. CTDST SRC LTM, that is destination to source lifetime. This refers to the duration of the time the destination to the source communication is active, providing insights into the time taken for bidirectional communication. Then we have is CTSRC LTM, that is source lifetime. This is the total lifetime or duration that source is engaged in communication. It helps to assess the longevity of a connection or session initiated from the source. Coming to CTSRC DSC, that is Server to destination communication, it refers to the interaction of data flow from the server to the destination address, client, or another server. It provides insights into how the server is communicating with the destination point into the network. So this is all about the parameters. Now let's enter them. For that, we have the sample file opened. So here we have different types of attacks. Total, we have 6 types of attacks. Let's try them. Let's try with the class 2 first. So let's select the class 2, click on OK. And now let's enter them. So here the rate we have is 10, it's 1 lakh. So give the rate as 1 lakh. And the next we have is STTL, that is 254. And next we have is deload, that is download 0. Acknowledgement date is 0. Daemon is 0. CTSRV SRC is 14. CTDST Sport LTM is 6. CTDST SRC LTM is also 6. CTSRC LTM is 6. And the last one is 14. Now click on predict. So the given data will be pre-processed at the backend and then we will be getting the prediction. So just wait for a while. So here we got the prediction that attack is detected and the attack type is fuzzers. Now let's check with the other class. So let's try with the class 0. Click on OK. So now we will use the first test case of class 0. So paste the rate, then enter the other values where STTL value is 254, deload value is 0, ACK is 0, daemon is 0, CTSRV value is 20, CTDST is 6, and the next two are also 6. And the next value we have is 18. So click on predict. And here the input has been processed at the backend and the train model has given the prediction that attack is detected and the attack type is DDoS attack. It is DDoS attack. Now let's check with the other case. Let's try with the class 1 of the first test case. Copy the rate. And here STTL is 254. Deload is 0. ACKDAT is 0. Dmin is 0. CTSRV is 7. 2 is CTDST. 7. 3. 7. Now click on predict. So here based on the given information, here we got the prediction that attack is detected and that attack type is exploits attack. Let's try using the other 3 test cases. We have completed 0, 1 and 2. Let's try with the third test case, that is third class. So let's try with this. So select the rate. Next STTL value is 254, 0, 0, and the next value is 0. Next 3 values are 18, 20, and the last one is 18. So here we got the prediction that attack is detected and the attack type is generic attack. It is the generic attack detected. So here class 3 refers to the generic attack. Now let's try with the class 4. So copy the rate. We will be trying with the first test case. Paste the rate here. And next we have is STTL, that is 254. Deload is 0, 0, 0, 5, 1, 4, 2, and 4. Click on predict. So here we got the prediction that is no attack detected and it is normal. So here there is no attack. So that is why here we got the detection as no attack detected. Let's check with the last case where it is 5 class label. That is the 5th class type. So let's try with this test case. So copy the rate, and the next one is STL, that is 254. D load value is 8246. Next one ACKDT. So next we have is 45. So 45, 1, and all the rest values are 1. Now click on predict. So based on the given input, here we will be getting the prediction. So here attack is detected and the attack type is reconnaissance attack. So it is the reconnaissance attack. Now let's check with the graphs. Click on graph. So here the first graph which we have is the sample outcome graph. Here on x-axis we have the attack types that are the class labels, and here on the y-axis we have the count. So this sample outcome graph shows the class distribution. Here, if you observe, normal cases are more than the attacks. So here we have DOS attack, exploits, fuzzers, generic reconnaissance. So these attacks count is less than the normal case. So here you can observe the class imbalance. That is why we have used the class data balancing technique, that is nothing but the smooth synthetic minority oversampling technique. And this is the correlation matrix graph, which shows the correlation between the variables. And here these are the algorithms built on the feature selected using the filter method. So this is the accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithm names. Here if you observe, extension model is having the highest accuracy. And this is the precision comparison graph. This is the recall, FN score. And these are all the evaluation metrics used to evaluate the project. So this is the wrapper method using which we have done the feature selection. After selecting features using wrapper method, these are the algorithms trained on the data set, feature selected on wrapper method. So this is the accuracy comparison graph, precision, recall, and FN score. And here we have the embedded method. So we have selected features using embedded method, and we have trained all the algorithms on the feature selected using embedded method. And here we have accuracy, precision, recall, and FN score. Similarly, here we have the PCC, that is Pearson correlation coefficient. So we have used this PCC for selecting important features. After selection, we have trained all these algorithms on the feature selected using PCC. And this is the accuracy, precision, recall, and FN score. So now click on sign out. In this, which is by giving inputs to the system will classify the attack. So if there is attack, it will detect which type of attack it is. If there is no attack, it will show that there is no attack detected. So this is how it will help the users. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.